that this was the state diagram of cconf212. So from this table, so we have made this table, and this was the output and this was the input, and whatever the transition has been occurred, and we have written that output and corresponding input above the directional line. That means if there is any self loop, so we have written the input and corresponding output. Okay, so 0 1, like when SA is a present state, when SA, SB, SC and SD, these are all the present state. And when I'm coming from present state to again next state as present state, that means we are starting from SA and we are ending up to SA. So there is a self loop is being used, and this is the corresponding condition. That means 0 is the input and 0 0 is the output. And when for the SD, so these are all the transition conditions. Okay, so when SA will be transformed to SB, this was the condition. That means the input to be considered as 1 and output is 1 1. So in this way, this was the state diagram. Okay, right? So what we will do now, the same state diagram, I'm just modifying it, keeping in mind that the state diagram will be starting from 0 0, that means all 0 state, and it will end at all 0 state. So we will consider SA, because here also we have considered the present state as SA equals to 0 0, right? And we will write only output, and also we will determine the weight of the outputs. Weight of the outputs means, that means what is the weight of 0 0? This sequence, what is the weight? The number of 1 present is 0, so that is why the weight is also 0. What is the weight of 1 1? This is 2. What is the weight of 0 1? This is 1, because one number of 1 is present. There is 2 number of 1 is present, so that's why the weight is 2. Now again, for the 1 0, also the weight of 1 0 is 1, because one number of 1 is present. So this is the concepts we will use in the modified state diagram. So we will use the outputs and the weight of the output. So please remember that what was the output corresponding to the transition, like from A to A, the output was 0 0. From A to B, the output was 1 1. From B to C, the output was 0 1. From B to D. So you have to just remember all the outputs of the transitions. Rather, you have to make this table, okay, to make this modified state diagram. So now I'm going to our previous thing. So that is my traditional diagram. So I'm just writing, this is the same structure as before. That means this structure, okay, in your previous lecture or previous PDF. So this is, so I'm just writing only outputs, not this 0, this 1, this 1. So I'm just not bothered about this input. I'm just writing only the output. Okay. So first of all, this is the traditional diagram. So as you can see that this is a self loop, same as before, like SA is going to SA again, SD is going to SD again. So this is the corresponding output. So like I'm saying that I'm only writing the output. Okay. I'm not writing the corresponding inputs. I'm only writing the output. 0 0 1 1 1 0. So when SB is transforming to the SD, so this is the corresponding output. This is 1 0. Okay. Now I have already told you, you have to write this output, you have to consider this output, and you have to consider the weight of this output. Okay, so what is the function? Now this is our traditional state diagram of cconf T212. Now keeping in mind that modified diagram starts and ends in the all 0 state SA. So this is my first condition. Okay, so my modified state diagram will be starting from SA. Like you can see, the modified state diagram starting from SA. This is start. As you can see, this is start and end at the all 0 state. That is SA also. Okay. because SA equals to my 0 0, all 0 state. So the first condition is satisfied. So what is that? The thing is that the modified state diagram starts and end in the all 0 state AC. Okay, so now you can see from this diagram that this is starting from AC and end at AC. Now the thing is that from when I'm starting from AC, so what is the transition? From AC we are going to SB. That means you can see from this traditional diagram, that is SA to SB. So we are going from SA to SB, like SA to SB. Okay, so I've already told you that we will consider the output. What is the output? This is 1 1. And what is the weight of the output? This is 2, because there is 2 number of 1 is present, so this is 2. So that's why I'm writing this is SA to SB. So all possible path I'm considering, this is start where I'm starting from all 0 state, which is SA, and end at all 0 state, which is SA. So in between, what is the possible paths starting from SA to AC? Okay, so I'm starting from SA, so I'm going to SB. So this is my output and this is my weight. Weight of this output is 2. So I'm writing as x to the power 2. Okay. Now from SB to SC, sorry, from SB to SD. Okay. So this is my corresponding output, which is 1 0. So output is 1 0. So weight is 1. So that's why when SB to SD, x to the power 1. Okay. So this 1 2 is basically the weight of the output. Okay, so I'm just defining this x to the power 2, x to the power 1 as path gain, you can say, from the control system. So just taking x to the power 2 from SA to SB, from SA to SB the output is 1 1 and the weight of the output is 2. So that's why x to the power 2. When I'm going from SB to SD, the output is 1 0 and weight is 1. So that is why x to the power 1. So you can tell me that from when I'm going from SD to SC, that means SD to SC, right? The output is 1 0. So what is the weight of 1 0? 1, because there is one number of 1 is present. Okay, 1. So that's why again 1 x to the power 1. Now XC to XA, that means SC to SA. Again this is 1 1 1. So again the weight is x to the power 2. Okay, so in this way, so there is, you can see from this diagram, from this modified diagram, that there is two possible path to go from SA to AC. Okay, one is SA SB SC, sorry, SA SB HD SC SA, and one path is SA SB SC SA. That means one is this straight line, path, and one is SA this path. Okay, that means SA SB SD SC SA. Okay, there is two possible path, which is starting from SA and end at SA. So I hope you will understand that the significance of the weight. Okay, the weight. So when I'm calculating the weight of the output, so this is written that weight, it is T missing. Okay, so you know that weight of the corresponding output of each state transition, weight of the corresponding output of each state transition equals to I. So this is basically I. The value 2 is of I. Okay, I is basically defining the weight of the output. Okay, now I'm defining this path gain as x to the power I. Okay, like this. When I'm going, I'm just repeating for your understanding purpose, that is when I'm going from SA to SB, the output is 1 1, so weight is 2. So that's why I'm writing x to the power 2. when I'm going SP to SD.